Hi, everybody. Thanks for joining us. It's right at 6 o'clock, so I think we're going to go ahead and get started. I know a few more people are still logging in. But my name is Susan Langenhennick. I'm the Director of Communications for the Preservation Resource Center. And I'm thrilled that we could put on this program today. Obviously, this has been a very hot topic, no pun intended or pun intended. As we all experienced recently, extreme weather can happen at any time of year. Not just during hurricane season when most of us in New Orleans anticipate it. So I'm thrilled to be joined tonight by two of my PRC colleagues, Danielle Watson, who is our tech guru behind the scenes, who will be manning our Zoom platform and making sure everything works. And then my colleague, Nathan Lott, the PRC's Policy Research Director and Advocacy Coordinator, who's going to be helping with questions and the conversation. And of course, our esteemed speaker, Dr. Myron Katz, a building sciences expert. But before I introduce Dr. Katz, I wanted to welcome everyone, and especially our Preservation Resource Center members. The PRC is a 47-year-old nonprofit that works hard to protect and preserve our historic neighborhoods and architecture and cultural identity in the city of New Orleans. And we could not do it without our members and donors' support. We hold free classes and programs like this one throughout the year on all sorts of topics related to maintaining and preserving and celebrating our historic architecture. That is only possible through our members' help. So if you are not a member, we really encourage you to join or consider making a donation tonight. My colleague Danielle is going to put the link in our chat function, so you please join, because these free programs provide vital information to everyone, and clearly this one was a topic that was top of mind, especially last week. This program is just one of many that we've got planned on historic building maintenance, and specifically addressing issues related to buildings, older buildings in New Orleans and our climate. Stay tuned this spring. We are launching a series called Maintain Right, which will have a series of these Zoom webinars and also shorter social media worthy videos that will talk about topics about maintaining and caring for your older building. You can follow along with us on PRC social media or in our magazine, Preservation in Print, where we will have announcements about all of our upcoming programs. And one of the perks of being a member is that you get Preservation in Print magazine delivered to your door. So one more reason to join us. Finally, I just want to let y'all know about one upcoming fun event that we're planning at the PRC this spring. It's called Revival Galavant, and it's going to be a virtual fun run through many of our historic neighborhoods in New Orleans. And along with the routes, which will highlight a lot of our historic architecture and buildings, we'll also have podcasts, which are going to bring a lot of voices of local residents, as well as history and geography experts like Richard Campanella of Tulane University will be joining us on these podcasts. So it's going to be a lot of fun. Please stay tuned again to PRC social media for the launch of that fun program. Now I'm going to turn it over to my colleague Nathan, who's going to introduce Dr. Katz.
Yes, well, you forgot one thing about prcno.org, Susan, and that's the great swag that you can get there.
You're right, Nathan.
My Preservation Keep It Up Longer t-shirt, and you too can own this beautiful shirt or one of our other more or less cheeky t-shirts, tote bags, and other pieces of swag, so you can show off your preservation pride as well. As becoming a member when you go to prcno.org. So just a little housekeeping before we get started. Everyone who is joining us as a guest is muted and your videos are not active. So you can't Zoom bomb us, but that also means you'll have to type your questions. We received many questions in advance by email, some by social media, but we also hope to have time for questions that we receive via Q&A. So you can put your questions into the chat function below. If you'll do that, I'll be monitoring it during Dr. Katz's talk, and we'll do our best to be sure that we answer as many of your questions as we can. And we definitely plan to do future programs on specific aspects of this topic. So I know we probably won't be able to get to everyone's questions. So bear with us and know that there's going to be more to come, as Susan was alluding to. And now I'm pleased to get to introduce our special guest speaker, co-founder and principal of Building Science Innovators. Dr. Katz has a doctorate in mathematics from the University of California at Berkeley, and he holds energy and building science certificates from the states of Louisiana and Florida, as well as associations, including the Indoor Air Quality Association, the Association of Energy Engineers, and the Residential Energy Services Network. His projects on historic buildings have included moisture prevention and energy efficiency work on the former house of Boltman Funeral Home. That building is at the corner of St. Charles and Louisiana, and you might remember it or recognize it now as a Fresh Market grocery. And he's worked on cures for rising damp moisture inside the 200-year-old Jackson Barracks and the Louisiana National Guard headquarters, as well as a historic restoration of a 140-year-old shotgun double. Dr. Katz has 3 decades of experience as a residential and commercial energy and moisture consultant, specializing
Nathan, I think we lost your audio. Hold on one second. We're going to try to get you back.
energy efficiency, forward-thinking policies.
Nathan, I think we lost your audio for a few minutes there. You might want to back up a little. I think we lost you when you were talking about some of Dr. Katz after you talked about Jackson Barracks.
Okay, well, so in addition to working on rising damp at Jackson Barracks and Louisiana National Guard headquarters, he has overseen restoration of a 140-year-old shotgun double. He has 3 decades of experience as a residential and commercial energy and moisture consultant. Dr. Katz specializes in retrofitting Southern Louisiana buildings to make them healthier, safe, reliable, durable, and comfortable. And he's also, in addition to serving on several energy policy task forces, consistent advocate lobbying the city of New Orleans for energy forward-thinking policies. So without further ado, I yield the floor to you, Dr. Katz. Thank you so much for joining us.
Thank you. You can hear me now? I guess so, huh? Okay, so I'm going to share my screen, and this way I'll be able to, do it this way. Let's see, this way, and then go to this one. Okay, I think you can see my screen now. Someone like Daniel or someone, if you can see my screen, I want to be sure. Okay. Okay. So this is my my Word document that I prepared for this talk, and I go to the very bottom. This is what I'm supposed to say. So hi, I'm Myron Katz, co-owner of a company called Building Science Innovators. I'd like to thank Susan Leonarding and the Preservation Resource Center for inviting me to answer your most pressing questions on promoting energy efficiency in New Orleans homes. I'll start right into addressing a series of questions that have been sent, answering those first that have been prioritized by Susan as being most useful to the largest number of people. And after that, there'll be a Q&A. I won't get to all the questions listed in my hand up, but you can always contact me and I'll see what I can do. I'm going to address these questions 1, 2, and 3 together since they're all related. I also created a Word document. This Word document, it's full of active links, and I have shared it, and it will be shared on, you'll see it in the chat session very soon. Okay, so the questions I'm going to deal with are the first 7 on this list. And so the first question is, what's the single biggest improvement you can make to improve the energy efficiency of your home? So I know you can't read what's coming up, so I purposely made it smaller so I can make it bigger, and then it won't take all the space the whole time. So here's the answer. Since you asked the doctor, since I've called Dr. Katz, my advice is this is the wrong question. What you really want is more reliability, comfort, safety, health, durability, and less pests, all for less money. And we can get all that done and have a negative carbon footprint. Yes, we can do that. So here's my prescription. How about an 80% energy efficiency upgrade with Wi-Fi control, batteries or electric vehicle, a microgrid, and more load flexibility than load and a 3-year payback. I want to explain exactly what all that means unless someone asks me, but we're going to focus on the energy efficiency upgrade part. To get a taste of success right at the beginning with a Wi-Fi controlled, super energy efficient heat pump water heater and see how far it takes us. And then we'll make your home tighter with 1/3. Make your home tighter with 1/3 natural air changes per hour and very well insulated home. I'm getting some hearing in the background, I don't know why. And make your home effectively built on a slab. So I'm going to do that with a series of graphics. And these graphics literally come from links on this page. So I'm going to minimize this size again and show you where the links are so you can find them yourself. So this is one of the links we're going to go to, Air Seal Your Home. And we're going to go that afterwards, but I'm going to go there first so you can see what I'm talking about. Let's see. Go up to 16 on this. And this is a link right here. Air Seal Your Home is an active link, as well as very well insulated, as well as use membranes. But before I go there, I want to show you an important graphic. So this is a graphic from the Florida Solar Energy Center. And it's talking about reference homes. This is talking about a brand new home that's code compliant in Florida. And Florida is one of the strictest building codes in the country, and they've had building codes longer than almost every place else in the country. And they have very energy efficient homes. Yet the homes in northern Florida and southern Florida are very different. You can see that there's a lot more cooling in Miami than there is in Tallahassee. And we're more like Tallahassee. We're pretty much the same latitude. So think about the graph on the left. So what does this graph say? What this says is that of all the money you spend on electricity or gas to cool and heat your home, this is how it's broken up. Namely, about 1/6 is water heating, and 1/6 is cooling, and 1/6 is cooling your heating your house, and then maybe 1/7 is on refrigeration, and then the dryer, and then the stove, and the lights, etc. Now, this turns out not to be your curve if you have an old home, because, or your pie chart, because this is a new home built on a slab, very energy efficient, not leaky, namely not an old New Orleans home. And to think about what this home would be, to give a perspective, this water heating slice right here of the pie is somewhere between $200 and $300. For example, if you have an electric water heater, you might spend over $350 for hot water. If you have a gas water heater, it might be half that. So this is averaging around $200. To give you an idea what all these numbers stand for. However, I'm sure your cooling bill is a lot more than $200 or $300, and that's because you have a leaky home and it's not on a slab. And we're going to see if we can make your home act as if it's not leaky. It is well insulated and it's on a slab, and that's what we're going to focus on next. But this part of the pie chart, the cooling and heating, is probably around 60% of your bill in New Orleans because you have a leaky home not on a slab. And I'm going to explain how we do that. So first of all, I want to tell you what I promised. Remember I said I want to get your home 80% more energy efficient than it was before. And the first thing I recommend, since it was asked what's the most energy efficient thing you can do, is buy this water heater. This is a water heater that's 4 times as efficient as the one that you have, which means that $200 cost for water heating will now go down to $50. And it costs under $1,400, but you get $700 in rebates, which means you get it for $700, and you're going to save $150 a year. So you'll pay for this in maybe 3 or 4 years. So this is a super solution, and it is controlled by Wi-Fi. You might say, why do I care that it's controlled by Wi-Fi? Because it's going to turn out in the future, being able to manipulate appliances are going to have a big effect on your energy bill in ways that you don't understand now. And maybe we'll get to that. So what's the problem of making homes tighter? That's what this picture is about. Now, I want to point out that I use graphics that are on the internet because they're better than I can make. And I need to not cheat and not give, this is where it came from, Go Energy Pro. And so I don't want to violate any copyright rules. But that is just so you can see this really nice graphic. This graphic is for a company that's national, and most of the homes in the country have big energy bills because of cooling, keeping warm in the the winter, and therefore they see cold air coming in. Wish we could have cold air coming in the summer, but this is cold air coming in the winter at a home that is leaky, much like your leaky home, okay? And then showing all the various places homes air can leak in. It can leak in through the windows, and that's why we might want to tighten the windows and doors. It can leak in through the attic hatch, which is right here, and they actually recommend using this attic tent to seal that. They also can go in around your stud cavities, namely up the wall here. It can go away the stripping to the attic. We just mentioned the attic access door. And so this company, which probably sells a retrofit for around $1,000 to $1,500, promises, so to speak, that they will give you an $800 savings from all these various things. So what are these various things? Okay, well, this is a Nest thermostat. This is the thermostat on your air conditioner, which will change when the heating and cooling occurs, as I explained before, or at least suggested. Sometimes it's smart to have your thermostat set higher or lower. It saves money on your bill. Then your lighting package going to LED could be a lot less than this if you have fluorescent, or as much as this and more if it's incandescent. A smart strip you may not have heard of. It's just a regular electric strip that you have your television and maybe your cable box and other things connected. And obviously you can't use your cable box if your TV is not working. And so this device notices that your TV is off and turns off your cable box and saves you a lot of energy. You may not know this, but your cable box uses about $40 worth of electricity a year. So the smart strip saves quite a bit of that energy. Air sealing is what we talked about. It's the primary goal. They also seal the ductwork if you happen to have ducts, and they wrap the water heater for a total of around $800. And this has a lot to do with the air sealing we were talking about. However, you may notice that there is nothing here about improving the insulation in this particular set of retrofits. And they don't talk about the fact that the insulation on the floor of the attic, which is the same problem in your home, needs to be in an airtight container in order for it not to work as an insulator. Obviously, if air is flowing through the insulation as shown in this place in the picture, okay, it's not going to act as an insulator. For example, if we're fiberglass baths are good for heating and cooling as long as they're enclosed, but the same kind of fiberglass is in your air condition register. And so how does the fiberglass know, oh, I'm a filter over here, oh, I'm an insulator over here? It doesn't. If it's not an airtight container, it doesn't act as an insulator. So how do we get it to act as an insulator? Or what do we need to do to retrofit this attic so it works better? So in the South, there is something else that we need to do to this attic, and that's called putting in a radiant barrier. So this is a graphic from another company. I don't know who made this picture, but again, giving people credit. This is from Service One Attic. I don't know who they are, but nevertheless, there they are. And this is their graphic. So I have a radiant barrier, and I've recommended radiant barriers to almost every one of my clients, and most of them take my advice. And it may be too hard for you to see, but this says 97%, namely 97% of the radiant heat that comes off the bottom of your roof deck when it's heated up by the sun will go through if there's no radiant barrier, and will not go through if the radiant barrier is there. That is a big effect. An attic like this in New Orleans without a radiant barrier could get to 140 to 150 degrees in the summer. Assuming a black roof, a radiant barrier can easily keep that down to 120 or even maybe 100. And that's a big difference, because the lower the temperature is, the better this air conditioner is going to work and the better this insulation is going to work. But it turns out it's not the only thing you need to do to your attic or to your home to make your insulation work better. This is a very interesting phenomenon called membranes improve insulation efficiency. I'm going to go back to the top of this thing, and I'm going to remind you that that's the name of it. Membranes improve insulation efficiency. And that is the name of this particular slide in my Building Science Innovator website. You can get here. And what happened is this guy, Chris Bullock, in 1985 was a high school student. It's a long story about how he did this and why he did it and so forth. But nevertheless, he figured out that if you don't put plastic over the insulation, it doesn't work as well. In fact, the R value of the insulation changed because of the plastic by a factor of 10 if covered by a membrane, and even greater or maybe even by a factor of 30 if covered by a membrane. And strangely enough, the membrane actually didn't trap moisture, and just the opposite, it made the insulation drier. And you may not know this, but the effectiveness of insulation actually drastically decreases when it gets wet. So this made the insulation work better, and it kept the airflows out of the insulation, and so the insulation worked. So these are things that people don't know. So I'll go back to this picture here. I would recommend covering this entire attic floor with 2 mil visqueen, and underneath this roof, put in a radiant barrier. And that goes a long way towards saying what I said to do, namely seal the home and make it very well insulated.
Dr. Katz, can I ask you, just for folks who maybe aren't as up on this topic as a lot of us, what the R factor is? Can you give us a brief explanation of that? You mentioned it in the last slide.
Okay, so thank you for asking that. Turns out an R factor is a calculation of how fast heat flows through a material. So the easiest material to understand is a piece of wood. So if a wood has the value of R flow is like, if you have an inch of wood, the speed at which heat flows through an inch of wood is R1. And cellulose, the same thickness of cellulose will be R3. Okay, and on the other hand, if it were brick, it would be R.1. So that gives you an idea of what the insulating value of materials are. The higher the R value, the better the insulator, and the more fluffy the material is, the better the insulator, and the denser the material, the poorer the insulator. And that should give you a pretty good idea of what we want. What we want is fluffy stuff that's not compacted and doesn't have airflows through it, so that it can act as an insulator. I hope that answers your question. Here's another example, by the way. Here's fiberglass back on the back of this knee wall, that's what it's called. And there's no plastic on that, which means it's not going to work very well. Anyway, these are the kinds of things that people don't understand and need to be improved. Do not think insulation is an airflow barrier or an airflow barrier is insulation. They are different things. You don't get one when you do the other, but you can make them work together. And if you don't have them both working well and in the same place, your building shell will not work. So these are the kinds of details. So going back to the talk outline.
Before you
yes,
go away from that, so if someone wanted to bring someone in to help them improve the attic in these ways,
I forgot
who
to
would you
mention
recommend?
I forgot to mention that. I apologize.
No, just so I know that a lot of people, there's a lot of information coming at them, including me. And so we want to make sure we know what we're doing.
Right, here's the answer. It's on the slide. I just forgot to get to it. Thank you for reminding me, Susan. This is how you can tell if the people know what they're doing. I am a certified energy rater and even an energy rater trainer, although I've never been certified by BPI. Other people are certified BPI, and they're actually become home performance contractors. So Resnet actually invented the process of testing to see how leaky a home is. And actually some of the solutions, and BPI is focused on fixing it. So this is a good team. And someone with either or both of these are going to be the kind of people you want. And this company over here, Home Energy X Specialists, that's just a name. There are probably at least 1,000, maybe 10 or 20,000 companies in the country that have these kinds of certifications. In fact, I know for a fact that the people who run the Energy Star program in New Orleans, which is our demand side management program, started off with this certification, the BPI certification, because I know the guy that did it. So let's go on to the next part of my talk. And thank you, Susan, for making sure I don't forget to say something I plan to say.
Sorry to jump in, but I just want to make sure that people, when they're looking for a contractor to do this work, they know how to evaluate whether they're somebody that's
right. I also want to say one more thing. This NaCH means natural air changes per hour. You may have not noticed it, but it was in this section right here, which I'll highlight for a minute. It's right here, and I'll make that 18 so you can see it. NaCH means natural air changes per hour. That means if you don't have a fan, how much air blows through your house. So if your house has, say, 20,000 cubic feet of air, and all that air blows through your house in 1 hour, that's called one natural air change per hour. So a home that's relatively tight, it takes 3 hours for the air to blow through. Homes in New Orleans, usually you have 2 natural air changes per hour. I've done hundreds of tests on homes in New Orleans, and I can say it's not unusual for a home that hasn't been made tight, a normal old home will have 2 to 5 natural air changes per hour, where what the industry wants is 1/3 or 6 to 12 times as tight. And so if you never get it that tight, then you need to make it tighter. But if you get it tighter than that, you need to talk about another way to bring air into your home, because it'll get stuffy and it won't be good for your health. So these are important conditions of success. You don't know what you're not gonna succeed if you don't know what you're trying for. So I'm gonna make that small again, and also this part, and talk about how we're going to make the home seem like it's on a slab. So the way to do that is what I'm going to talk about now. Okay, I remind you that that was the last thing I said I was going to do in the first part of the talk. I'm going to open that up again and tell you that it should be on a slab. Make your home effectively built on a slab. So how do you do that? And you do that by what's called closing a crawl space. And it's very rare that people in New Orleans do it, but it turns out to be not an invention that came from New Orleans, but it is something very important that we should be doing. So I'm going to show you the things related to this. And it turns out a company called Advanced Energy, which is located in North Carolina, pioneered the technology and did a series of studies on it. And then not long after that, I created a PDF file that I'm going to show you how you can get access to on my website, which explains one of many solutions for doing that. And another company out of Atlanta made a study on it. And I'm going to, if we remind me, I'll show you pictures of a work in progress I'm working on in an uptown shotgun double. So let's go to those particular places in the, let's see now, let's see, where is this one? This one is not telling me where you are. Let's see. It should be telling me, okay. I can't see what it is. I may go to the wrong place. So this is the right place. Okay. So this is the Advanced Energy Report that came out in 2005, I think. And this is a company in North Carolina, and they invented the notion of closed crawl spaces and did a tremendous amount of study. And one of the things, for example, that people thought was, you know, if a home is too tight, it's going to have a moisture problem. But they in fact had there was a problem where there was too much moisture in a home, and one contractor said, put in a fan. So they put in a fan, and this joist, that's the bottom of the house, so the insulation, got so wet that they could stick a penknife through the piece of wood. And so clearly, more ventilation wasn't the solution. They wanted to see if they did just the opposite and closed it. And they did a large study, and they showed, in fact, it was very successful. And they created a whole design procedure here. And you can use this design procedure if you want. But it turns out that no climate is the same as another climate. Some of these climates work better than others. So what is needed in North Carolina may not be needed in New Orleans. And I think I found a simpler solution that works very well. However, I'm not the only one who came up with a solution. As I said before, Energy Vanguard did, and I'm going to quickly tell you what they said. They said that in the Advanced Energy Study of 2002, that your relative humidity was stayed very low, under 60% throughout the summer, from June all the way to September, whereas in a vented crawl space, it went way all over the place. And these high moisture values can be very deleterious to your insulation and to your wood products and so forth. And so the question is, how do they do it? So Advanced Energy actually has a very aggressive approach to closing crawl spaces. They don't have it in this picture, but that's okay. I'm going to show you the approach that I came up with. So this is an approach that's on my website. It's called Closing Crawl Spaces in Historic Homes. And again, you can get to it by going to my website and looking for Closing Crawl Space in Historic Homes. It's in one of the drop-down menus. In order for you to understand it, I decided I needed to actually figure out how to do this. And I went to a lot of trouble. I dealt with LSU and the Louisiana House and the Louisiana Structural Pest Control Commission, which you may not know. That means termites. And if we do something wrong, we might invite termites, and termites are worse than the energy problem in your home. So we definitely don't want to do that. So anyway, what's nice about New Orleans is our ground stays close to 71 degrees all year round, which means it's really kind of dumb to insulate ourselves from the ground because the ground is warmer than we need in the winter and cooler than we need in the summer. And so it always is a good thing that you want to be in thermal contact with. So way back in 2011, almost a decade after Advanced Energy produced their report, I decided I was going to create a similar report. So to get people really understanding the architecture, this is a layout of a 60 by 25 home where these are the piers. And of course, I never built a home, but I imagine they might be built this way. And you put the piers, then you put the sills on top of that, and then you put the joists on the sills. If I'm going too fast for you, I hope not. And then you put the studs on the sills. No, this is balloon frame construction, not the way they build new houses. Namely, in new houses, they put joists, studs on top of floor, but the floor hasn't been installed yet. And here's the weather boards going up and some more weather boards. And because you always want to finish outside in, and then just so you can see the joists through a temporarily or virtually removed walls of the building. And now we're going to put the floor on the joists. So you have a pretty good idea what a home looks like. And if you go underneath that home, which I hope many of you have been underneath a home, this is what it looks like. Although I have it painted blue, you're not going to really see the blue side of the exterior walls, but this is what you see. And this is what you start with to put your insulation in. So I actually decided one of the key steps in all the recommendations is to cover the ground with 6 mil visqueen. And unfortunately, in New Orleans, most homes are full of trash. You need to clear the trash. We'll assume you've cleaned the trash, and then you start putting in various items, but leaving the extra 6 mil visqueen along the edge everywhere. And so you're going to see how I've done that. There's something here, aluminum placed to protect the bottom of the sills from the structure that I'm going to put up. And then I'm going to put some beams here to support the foam boards. And then I put plastic on the ground. That's what this line over here refers to. And then I hang my foam boards. And now pretty much completed. Here's another view of it from the inside. Here's another view from the side. And notice that there's a 3-inch air gap above and below the foam board because we're more interested in making it airtight than insulated. And also because the foam is a passageway for termites, it's not a good idea that you want your termite inspector to be able to see above and below the foam. And so this actually was presented to the Louisiana Pest Control Commission a few months before I published this document to give people confidence that this could be done. Now, is this the best way to do it? I don't think so. In fact, I've actually never had anyone do it this way, even though I've recommended this many, many times to people. Maybe it's because it seems so hard they can't clear their crawl space. I'm not sure what it is, but I do know that people have done it and it can be very, very effective. And so I actually tried. So on my own website, where I actually tried doing it, I have some pictures of what are the various views I've done on a home in New Orleans. And you can see the foam board is placed between the piers here. And I'll get back to this if we want to later in the talk. So let's go back to the
Can I interrupt this for a quick second, Dr. Katz? I will say, since we're the Preservation Resource Center and we work with our governmental bodies here, like the Historic District Landmarks Commission and VCC, if you have a home in a full controlled district, you would need to get approval for any of these kinds of changes. So just have to give that little caveat.
No, and I so agree. I do not claim to be the aesthetic police. I am the building science police, not the aesthetic police. And there are ways to dress up so you don't have to see the foam board, lattice, so forth, are between piers in lots of homes. And by putting a black coating or something or a black cover on the foam, you can make it look like anything you want. That's not my job. My job is science, not aesthetics. I'm not going to say I'm opposed to aesthetics. It's just not my job. So anyway, but basically what we've done is put the home on a slab. And because we put the home on the slab, we're going to get the kind of energy flows and distribution of costs that we found in Florida. Going back to the example in Florida, I just remind you, you get a tremendous energy savings from that approach. And I again show you the Florida example. We want to get to this condition, okay? Now, that goes a long way towards solving the problem, but this is not specifically very energy efficient water heaters or cooling or heating systems. We're going to have to go that as well to get to that kind of price performance. but at least we've gotten rid of the major problems. Okay, so another question that was brought up, Susan suggested, is what happens if you want to use trees or other ways of shielding your house from the sun?
Before we move forward, I do have one question that I think is very pertinent getting back before we get off topic. One person asks, and it is a little confusing, why would you put visqueen on the ground? Can you talk a little bit about what that is doing?
Sure, let me go to that part in the slide. So let's see, am I, and no, I'm not in it. I'm in something else. I think I am. Wait a minute. Oh, no, I'm in something else. That's right. This is their recommendation, and they say you need to put plastic on the ground. Why is there plastic on the ground? Well, in cold climates, you can actually have colder air over the plastic than you have under the plastic, and moisture tends to move from hot to cold, and so the moisture can go into the attic, into the crawl space. Now, we don't really have much of that problem, but in a place like North Carolina or Boston or some place where they do this, that could be a very common problem. So cold air can get into above the plastic, and there'll be a moisture flow from the ground into the crawl space, adding humidity to the crawl space. So in that case, you really need to seal the plastic. I don't recommend sealing because we have another problem, which is flooding in New Orleans, and the water needs to come out after a flood. And we could have a flood tomorrow on no notice, so we can't have a sealed crawl space. And we seldom have very cold air. However, it is true that the moisture will come from the ground into the crawl space, and we want to slow that down. So slowing it down, you can do very well with 6 mil visqueen, but you do not want to seal it, even though it's recommended by both the people in North Carolina and the people in Atlanta. But we don't have that kind of a cold winter, so that's why I don't recommend it. Does that answer your question, Susan?
Well, but you would still put the visqueen down, you just don't seal it. So you would put it down with like bricks on top of it, or
Yes.
some other way that it could be moved?
Right, you move with bricks. And the interesting thing about
So it's just not sealed in place.
right, not sealed in place. And this is a very interesting thing about buildings. Buildings are almost never built correctly. I mean, not according to the architect's description. And in my opinion, if something has to be done perfectly, then don't even try, because it's not going to happen, because unless the homeowner does it and he never brings in an electrician or a plumber or a carpenter, it's going to get messed up. So it's just not going to stay. And so I only recommend things that will work if they're done 95% well. And this is an example of this. The crawl space solution will work well, even if the plastic is not put down perfectly.
So let me just make sure I fully understand, and I hope, I mean, I may be denser than some of our participants who are watching this, but so you would put visqueen under the house, just in place with bricks or something holding it there, but not permanently. And then you would enclose the crawl space, because then that traps the moisture, the heat that is coming off the ground, which is warmer than the air in the winter and probably cooler in the summer, and then creates the building envelope being all one. Your
Right.
above ground piece and your below ground piece. Is that correct?
Right. Your home acts almost as if it's on a slab, because it's transferring heat to the ground and from the ground. Yes, that's what you're trying to do. You're not going to do a perfect job, because you're not going to do this kind of retrofit. But, I want to give people a solution that works very well, but it doesn't cost you an arm and a leg, and it doesn't cause it a problem on its own, because this kind of a closure would catch a lot of water in our floods, and we can have floods anytime in New Orleans. So
then if it's on bricks, you could just open it, let it drain out, put it back.
The thing is, if they're not sealed, then the water is going to get around the plastic and get to the ground somewhere, because it's not covered everywhere.
Okay.
So you don't have to worry too much about it. I have had some homes that moisture didn't go away as fast, and then you may have to do more active drying. In fact, some of their specifications for crawl spaces, closed crawl spaces, includes putting a supply duct in the crawl space or putting in a dehumidifier in it. I have not had that experience, but other people have had. And we just have to monitor a closed crawl space, because it can have that problem. And monitoring is actually very cheap. It's so cheap that I don't even mention it. But I'm not telling you that these things are trivial. On the contrary, I'm saying this example right here, this is a work in progress. This is not a complete solution. It's not sealed on the bottom. And it's not far from being complete, but it's not complete. And more details need to be watched and monitoring and so forth. But it's so far superior to the other solutions, cheaper and better, that it's smart to go down this road, which is my point.
So the other solutions that are often talked about are sealing under the floorboards with something like spray foam insulation. This is far superior, you're saying?
Oh, it's not only far superior in performance, because as I said before, the ground is warmer than your house in the winter and cooler than the house in the summer. So why would you want to insulate from that? But if you don't block the air from going in from the outside in the summer, then, and you cool your house below the outside dew point, which means the temperature at which condensation occurs, then you will definitely for sure have condensation coming into the foam or the fiberglass or the cellulose between there. Now, well, some people say, well, if you put foam and it's closed-cell foam and moisture can't go through it. Yes, 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 that's true. The trouble is nothing is done perfectly. Okay, so in order for foam to work perfectly, it has to be put in perfectly. And you also can have a leak. And you can have all kinds of leaks in your home, like a roof leak or a bathroom leak. And when that bathroom leak gets to the foam, it doesn't come out. And therefore, now you have rotten floors. So you don't solve your problem with foam. And I've many, many homes where people have sprayed foam, and sometimes the foam thickness is 1/8 of an inch right next to where it's 3 inches. And the guy who installed it doesn't care, and the homeowner doesn't go underneath to see it. So you get an extremely uneven job. This is very, very common. One of the big problems in construction, if you can't inspect it, you can't get it. This is a very easy to inspect solution. The other is very hard to inspect solution. So
one more question before we leave this. Someone asked about the gap, the 3-inch gap underneath the enclosure of your crawl space. Can you talk a little bit about what the point of that is?
Okay, this gap is yet to be sealed. The purpose of the gap is that you do not want a passageway from the ground to the wood underneath your house, because termites, although they can't consume the foam, they can burrow through it, and they often do burrow through things to keep themselves away from their deadly enemy, ants. So foam looks like a super highway to them, to the house. So you can't have soil touching foam and foam touching wood. In fact, you shouldn't have foam touching wood or soil. And there's a way in this retrofit to fix that. And the way you fix the bottom is that you roll up plastic on the bottom, or you attach plastic to the bottom of the foam, or you put bricks to keep the plastic up, some kind of way to keep the plastic up so you get it sealed. In the first retrofit suggestion I told you about, I actually had plastic glued to the foam. There are many ways to get the plastic there. That's trivial compared to all the other solutions we need to talk about. This is not a complete solution yet.
Okay. And then one question more was, how do you attach the foam boards to the piers?
This is strictly a friction attachment, strictly friction. Now, this is a good question because it comes into the issue that we're going to talk about in a second. I'm just going to jump to it. This is called efflorescence, and it comes up later in the talk, and I'm just jumping to it. Efflorescence is an effect that happens to brick. Everybody's brick piers, and when I say everyone, I'm like 99% of all brick piers in the whole city are drastically damaged by efflorescence, because the rising damp that comes into this brick literally pushes out the mortar. This home that what we're just looking at had at least 80% of its mortar removed in certain bricks, and it also damages the brick. Well, the right solution is then to go ahead and close, is you can see all these bricks have been covered with mortar all the way around. And this gives you a pretty confident that the termites aren't coming up the side of the brick on the way into the house or into the foam, and a consistent layer for friction. And you can see the foam boards are slightly bent because they're oversized purposely to provide the friction. And you can increase the friction if you want to by putting a metal backer rod on this to make it stiff, but it's strictly a friction connection.
And so when you mean friction, it's literally just held in there because it's just tight, like a friction rod on a shower curtain or something.
That's right, exactly. You can see the slight curve in each one of these. Namely, it's slightly oversized. Maybe this is around a 6 to 8 foot length. Maybe it's an inch or two longer and slightly oversized, and that keeps it in place.
So I just need to, again, stress that if anyone is doing this in a historic district, they would need to get HDLC approval for this. Nathan, do you have anything to add on that?
Not really. I mean, I do think there's probably some screening methods that could make something like this pretty unobtrusive, make it dissolve. I was just on a webinar today talking about screening for elevated houses in Mandeville, where they are elevating to get out of the coastal flood risk. So they have a whole prescription at their preservation commission of what's acceptable there. So I'm sure that we could develop something similar. And again, as you see in Dr. Katz's example there, you have a front porch condition. So the sides are going to be minimally visible depending on how the front porch is configured. So, you know, the HDLC is primarily concerned with what's visible from the street. So I think recessing it between the piers, screening it, you know, we could make this work. I'm not part of the commission, so I can't speak for them, but I think it would be about a dialogue. And I just want to add on a separate note for folks that have been entering their questions in the Q&A. I have been taking notes here. I have tried not to interrupt if it wasn't directly a clarifying question. So some of these questions are ones that we're not clarifying, so we'll get to them at the end of Dr. Katz's presentation.
Well, we only have 15 minutes left, so I'm going to try to get to the end of the talk, so there'll be time for questions. So let me see if I can get there, okay? But I do think this closed crawl space issue is paramount, so I'm glad that we did do it. So the other question was about what about shading a home? How would you do that from the sun? So I'm going to bring up this part of the talk so you can see it a little better. And I actually think that trees can be very, very dangerous to homes. And the best solution is solar screens. So I'm going to explain what I mean by that. So here is a slide, a video, a link where it talks about trees can be terrible to your home. This is an oak tree. And they're a wonderful thing, but they can have major problems for your foundation. Oaks are like this, poplars are like this, ash is like this. I have a big ash tree next to my house, and I've had to do a tremendous amount of shoring work or else get rid of the tree. So my choice is get rid of, no, I do the shoring work because I love trees, but it doesn't mean that isn't continuing to give me tremendous grief. And so I recommend if you're going to plant a tree like this, which you could do, make sure it's at least 20 or 30 feet from your home because it will undermine your home. That doesn't mean that there aren't trees that are nicer, but look at all the trees that are problematic. Most deciduous trees, black lotus, box elder, maple, silver maple, sweet gum, sycamore, and then many evergreens, all these various evergreens here, all do or can do these kinds of problems. So there are things you can do about it. I don't really believe roof barriers work on climate, but that's what these people think. Now, what is the right solution? In my opinion, the right solution is sunscreens. This is a solar screen. I don't know what the HDLC would say about a screen like this, but this is extremely effective. And you can get them in black and white. And the beautiful thing about these screens is you can take them off in the winter and get sunlight and put them on in the summer and shade your home. Remember, I talked to you before about control. Control is a very, very important energy efficiency. We don't want systems that we can't turn on and off. And there are various types of screens, all kinds of colors and so forth. This is the recommendation that's sort of universal for building energy design. So that's the recommend, I think, is the best solution. I'm not saying trees aren't good, but they can be a big problem. And the problems are often not worth the good, particularly if you care about the durability of your building. So I want to quickly go to the last two questions. And so this one is about air conditioner and sizing and what's the problem associated with that. It's a big deal, very important energy efficiency. And it's also very important to doing it right instead of wrong. So let's do it right instead of wrong. And this is there's three links here. The top 5 air duct issues and how to fix them, why an oversized air conditioner is a bad idea, and what's the best solution. So I'm going to go there right now. So here is a picture actually on a private website, but it's a public picture by the Department of Energy, and they point out that ducts have a tremendous problem. These are just 7 of the problems of ducts, but there's actually many more. They have all these things that make them work poorly, and leaks, return leaks, furniture blocking, leaks at the furnace, falling insulation. Right here in this picture, supply ducts can be a problem. There are kinks in the ductwork. These are common all over the country, but there's many other problems. If you happen to have your bedroom here, you have to heat the entire house, to cool the entire house to keep this room. which is a zoning issue, which is dumb. That's zone systems are far better, more energy efficient. When there's a leak, then also it causes an infiltration problem, because if the ducts leak, that means air is going in and not coming out, or air is coming in and not going out. Therefore, an unbalanced leak in the attic, which is extremely common, will cause more infiltration in the home. Also, the hot attics bring in hot air from the air conditioning system. And even the worst, the biggest problem of air conditioning equipment is that you need a slow airflow over the evaporator in order to dehumidify, but you need an high airflow to get the air flow through this kink duct and go to the remote room. So you can't have the air conditioner doing both, namely providing enough airspeed to get to the remote duct, and at the same time, a slow enough airspeed to get dehumidification. And since you need to do both, you do neither one well. And so it's a bad solution. In fact, I did a study for DOE in 2005, and we found that the average duct leakage in New Orleans or Louisiana is like 30%. And that means you lose more than half your energy before it gets to your home. So why fool around with this nonsense? And so therefore, what do? So let me just see what other people said. This is another group that I told you before is Energy Vanguard out of Atlanta. And they point out there are 2 or 3 reasons why you shouldn't have an oversized air conditioner. So I need to segue into it. Sizing an air conditioner is very important. If it's too big, it runs for a short time. You may not know this, but if an air conditioner doesn't run at least 10 minutes, it doesn't do any cooling at all. It just doesn't have time. So an oversized air conditioner doesn't do any drying. And if you don't dry, you're not comfortable. We know in New Orleans, it's the humidity, stupid. So if we don't dry, we're not getting the job done. So we're not comfortable, but there's a bigger insidious issue that this guy doesn't mention, although I know he knows it, he just didn't mention it, is that when the inside air is too wet, what we do is we turn the thermostat lower. And then we eventually turn the thermostat lower than the outside dew point, and that brings in condensation in our walls. We talked about earlier, condensation in the crawl space, but the same thing happens in our walls. And we see condensation, it can destroy our walls, our buildings, and it's more likely to happen in a home with oversized air conditioning. So these are another reasons why it's very, very hard to get an air conditioner installed with central. There's an alternative. It's called a ductless mini split air conditioner. And this comes from the Costco website. I don't know if everyone here is a member of Costco, but if you were a member, you would see a price here of $999. This is a 1-ton unit, and most homes in New Orleans can be made so they only need 1 or 2 tons. I know it sounds crazy. You may have a monster home, you may have a mansion, but for most of us who live in homes under 2,000 square feet, you probably have a 3 or 4 ton air conditioner. But if you do all the things we talked about, to insulate and weather strip and put in the radiant barrier, insulate the top plastic over the floor, you'll definitely get under 2 tons. So put 2 of these units in your house and you have all the cooling you need. And because you don't have ducts, you don't lose half the efficiency in the ducts. And because your system that you have is probably a SEER of more like 14 or 15, you're almost doubling the efficiency of the equipment. So when you take the 2 doubles, you're 4 times as efficient, the same kind of ratio of efficiency we saw in the water heater example. And this is also a Wi-Fi controlled unit. I forgot where it says that, but it says that somewhere. Yeah, with Wi-Fi, which means it can be remotely controlled, which again saves a lot of money. So we've now put in 3 pieces of equipment, and this also, by the way, doesn't say it in the website, but it also comes with a rebate from the city of around $250 to $500 rebate. So you get also a big discount on this. And this is what I recommend for air conditioning. So I go back to this picture, and I am going fast because I want to see if I can answer some questions. We're running low on time, but I'm trying. So, okay, so now the question is, what are the first signs of moisture in your home? So I'm going to make this visible, and we'll see what it says over here. It says actually 1, 2, 3, 4, 5, 6, 7, 8 kinds of moisture problems in your home. So let's go to the first one, warped floors. So warped floors is over here. This is what warped floors look like. Now, do you have warped floors? Do you ever see your floors that look like, wait a minute, I don't see it there. Do you ever see floors that look like that? My guess is 1/3 of the people in this video, in this seminar, has seen floors look like that. And it's not even unlikely in the middle of the summer that you will see this in your home. And if you see this, this is the canary in the coal mine. This is the easiest problem, moisture problem to fix in your home. And if you see it like this, you can fix it before it causes other problems. We talked before about overcooling a home and having moisture come in and cause the floors to warp, or moisture occurring in the walls. And all that really takes is closing the crawl space or changing your air conditioner so it does more cooling and more dehumidifying and less cooling like the ductless mini splits can do. Now, here's another example of a moisture problem. This one is what's going on in your ductwork. Your air conditioner didn't do enough drying, so this cool register has now conducted the condensate in the air, and then of course mold grows on it because it's also dirty. And here's another one where we're talking about leaks in your bathroom. Now this has nothing to do with your air conditioner, but it's a moisture problem. There's an easy fix for it, but it's not an issue that you want to ignore. Here's another problem where your ductwork is in a highly humid attic. Picture's going to come up in a minute, I hope. And we see this is ductwork in an attic. Well, if you have an attic that's hot and wet, then and the air conditioner is cold, it's going to cause condensation. They call it weak, sweaty ducts, but the ducts aren't sweating moisture like your body. The ducts are causing condensation. The condensation will drip down onto the floor of the attic and then perhaps through the insulation and perhaps through your ceiling. And you will see these problems. And these problems are not going to go away until you do a lot of work to fix your attic. And these problems are all caused by ductwork, which in my opinion is a big mistake. And I just showed you another one. Here's another problem that is a moisture problem. And this one is the one called mold. And mold is a lot less dangerous than people think it is, but we don't know which one's a dangerous one, so we treat them all as dangerous. But the truth is, this is a problem, again, associated with inefficient dehumidification and overcooling, and you cool the home below the outside dew point. And this is probably an exterior wall, and moisture is coming in, but can't get through the vinyl wallpaper, and it gets stuck there. And the mold actually eats the glue, and the vinyl wallpaper comes off. So one of the things that you don't want in your home is vinyl wallpaper anywhere, and certainly not near an exterior wall. Here's another one. This is called rising damp. Moisture comes in from the ground because this masonry product is very good at wicking moisture. Moisture comes in from the ground and then delaminates the paint. But that's not the worst. The worst is the one we mentioned a moment ago, is efflorescence. It comes out and actually causes the calcium and the moisture flow to come out, and with it comes out some of the mortar. So those are the issues that answer the last question. I wasn't asked to figure out how to fix it. That wasn't what I was asked. I showed you that. And I want to point out that I used a solution for it on the crawl space solution I talked about, namely coating the ducts, the piers with foam board. Oops, something went away. And there it is. I mean, not with foam, sorry, with mortar. And what that does is it keeps the efflorescence from hurting the mortar. It makes the wall look different. So what? That's the way it should be. Anyway, I'm finished my questions, probably with a few seconds left. I was planning a half an hour, but I didn't get to do it as fast as I wanted. So I don't know what to do.
Well, we can continue for a few minutes if you're okay with that, Dr. Katz, and try to get to a few of these, if you don't mind.
I don't mind.
One question that somebody just asked was, do the mini splits have heat? Or are they just ACs?
These are heat pumps, absolutely.
They're heat and AC, so.
Yeah, heat pumps, see?
Okay. So they're as efficient with heating as they are with cooling?
Yes.
And for folks who have not seen one of these, could you explain what it looks like in terms of how the air enters a room?
Here's
What's
it
the
doesn't have
register?
ducts.
This is outside. This is inside. There's a cassette
Okay.
on the wall about the size of a small suitcase, like a carry-on suitcase, tall carry-on suitcase on its side on the wall. And this is the Wi-Fi controller, and this is the outside unit, and this is the connector. It's called a line set, and various other things. And most cases, an installation like this through an exterior wall could be done in a day. I like them on interior walls, and they take 3 days, but so what? You can do them any place. You just have to make sure you have a place for the condensate. They're asked you to do the first one. The second one's real easy.
Somebody asked if you could do them under the house. Could you do that?
I don't know what the question means. You can't put the condenser under the house. It has to be outside. So this is the condenser part I call the outside unit. That has to be outside in contact with lots of airflow, like the condenser would be regular air conditioner. It has to be outside where there's a lot of airflow. So you can't put it under the house. But there are lots of places you can put it that's not in the front. And if it's not in the front, I don't think the HDLC will care.
One of
Yeah,
the units could cool or heat a room with high ceilings like we typically have in New Orleans?
Oh, absolutely. The problem isn't the height of the ceiling. The problem is how leaky the walls are and how insulated the walls are. In fact, one of the beauties of this system is you only cool from pretty much from this unit down. So if this unit's 6 feet up, it's only going to cool below. So if you don't put your ceiling fan on, it's only going to cool the air below. So if you have a 12-foot ceiling or a 16-foot ceiling, it's not a problem. You don't live there. So you live low, it cools it below. Now in the wintertime, it's not too terrific. It's going to heat everywhere and the hot air is going to rise. In that case, you probably need to use your ceiling fan to bring the hot air down. But at least you'll be warmer. And this system works. And this system works all over the country. In Maine, I don't know about Alaska, but all over the country. And it's used very, very effectively. This equipment, whole philosophy was designed in Japan. They have a relatively cold climate. And that's where it's been made better and better and better. And I probably put in some of the first ductless mini splits in the city way back in 2008 when they first got on the market. And I had to do it myself because I couldn't find an installer. And now they're common.
And I have kind of two related questions. One is, how do you get circulation from room to room? Do you put a register like that suitcase in every room or use fans to move the air through from room to room?
Okay, that's a good question. And it turns out this is not one that everybody agrees on. So let me tell you my opinion. My opinion is that you can put something equivalent to a bathroom exhaust fan in one room and send it through the attic to another room. Nothing more complicated than a bathroom exhaust fan. I've actually done that. I own an office building in Kenner, and I have a unit of around 400 to 500 square feet, and there's a door between one part of the office and the other. And so I have literally a bathroom exhaust fan immediately goes from one room to the other. And I just leave the fan on when I'm in cooling mode or heating mode, and it just keeps recirculating the air. That's a solution. Is it the best solution? No, but it's a lot better than putting in two of these units. But some people would think they need a unit in every room. And there are versions of the Mysticool, which I actually have for a shotgun double with 1,000 square feet on the side. I'm going to put in 4 of these that are three-quarters of a ton, 9,000 BTUs in order to spread out the cooling, and also allows for better zoning. And one of the things that I find slightly controversial, but in my opinion is reasonable, is I wouldn't cool a bathroom. Some people think you need to cool a bathroom. Anyway, that gets into details of issues. It's good to have one in every room, but you don't need them every room. You really need them on the exterior walls. The interior walls don't have any cooling load, so that's where you need it.
And in terms of multi-story properties, what's the best solution for a 3-story property? Would it be to have 3 separate zones?
You would need, these things are just like every other air conditioner. They make cool air and they fall down the stairs. So if you have a big stairway, this is a big problem with central units that people don't realize. If you have one central unit running a home and the air goes down the stairs, it doesn't care where you want it, it's going to go down the stairs. So the beautiful thing about this is you close the doors. Now, old homes have doors on rooms. New homes do not have doors on rooms, which is nutty, but that's the case. So if you can close the door, you can cool the room you're in. So if you have doors at the top of the stairs to the bedrooms, you can cool one room and not another room and whatever you want. So they're actually better for old homes than the problems that you're talking about. But they require logistical decisions. I've often gone into homes to try to figure out why they can't cool it. Is because they have these big stairways and they're trying to cool one room at the top of the stairs and they can't cool the bottom of the stairs or vice versa. And so it's better to put the cooling where you need it. And you can leave one room. Another thing that's real important is and this relates to the situation of last week. This time last week, people were freezing something off. And if in my home, I was able to, I don't have this exact kind of equipment, but I could concentrate all my heat into one room and let the rest of the house go down to 40 degrees. I didn't care. But that one room, I was totally up to 68 because I concentrated on heating that room. That's all I needed. Would I like to live that way all the time? No, but I can. And that's real important for resilience in case of a hurricane.
And that doesn't cause any problems like creating kind of thermoclines. I'm a scuba diver and we go through water and it's like you go through different layers and you get through these thermoclines. It feels like that's in a house sometimes where like one room's 40 degrees and one room's 68. That's not going to cause structural problems?
Yes, it will not cause a structural problem. Your house can tolerate that. The interesting thing about your house is it doesn't care about energy flows. The only time you can hurt your house is when you're trying to make the house cooler than the outside dew point. If you don't do that, you're not going to hurt your house. Or if you let your home get colder than freezing and then your pipes, froze like in Texas. So those are pretty much, the house itself doesn't care about temperature, almost at all. I'm not going to say there's no way you can cause a thermal shock on a home, but I've never seen it.
Okay, great.
Well, we do have another question about insulating pipes. Do you have recommendations on wrapping or insulating external pipes?
Okay, so the obvious answer is if the pipes are in the crawl space, the best solution is to close the crawl space and don't insulate the pipes, insulate the crawl space. If you are sort of stuck not wanting to do that, the best kind of pipes are PEX pipe. And I've actually talked to an expert in, and there's no reason why we have to look at this right now, but it might be better to look at this for a moment because we're looking at water heaters. So it turns out that water heaters make hot water, and you don't want your pipes to be hot all the time. You only want them to be hot the moment you ask for hot water. And it's just fine for your pipes to cool down to tepid when you're not asking for hot water. So of course, freezing is a whole nother issue, but the point of keeping the pipes from bursting, maybe that's a value of insulation. But if you're trying to make sure that the hot water that you put in, the heat you put in the water gets to your faucet, it's 10 times more important to have that water get there fast than whether the pipes are insulated. And I can tell you that from an expert, that's the way you do it. You design the plumbing so that the water goes to your pipes, go to your faucet quickly. You don't use recirculating pumps to keep the water hot all the time. So when you turn on the faucet, it's immediately hot. It's okay to wait 20 seconds for hot water. It's far more energy efficient to do that.
What about hot water on demand water heater?
Yes, yeah, that was one of the questions. What's the difference between on
Okay.
demand and the heat pump?
Okay, first of all, this is a water heater with a tank. So the issue of whether it's a heat pump or not is not the issue, it's whether it has a tank or not. I can explain what the water heater with the heat pump is second. So I believe that the Department of Energy owes this entire country a big apology for ever encouraging anyone to put an on-demand water heater of any kind, whether it's electric or gas. And the reason why is because the energy savings is tiny, but the alternative of not having a tank is a big sin. Why do I say it's a big sin? Well, because when energy is, it turns out the price of electricity and the carbon footprint of electricity, I'm gonna say this again, it's a little bit technical. The price and the carbon footprint of electricity is time dependent. Electricity actually is way cheaper and more carbon free in the middle of the night, most of the year because of the windmills in Iowa, which become a higher percentage of the wind energy on the grid, which is often sold at -1 cent a kilowatt hour in the middle of the night. So if you can heat your water with a water heater that heats your water at night and you use the water 12 hours later to take a shower, you actually do a very positive thing for the environment. And you would lower your energy bills if you had time of use rates, which I am promoting. But to get off that subject, this is a tanked water heater. A tankless water heater cannot do that. And it turns out the energy savings and the carbon footprint savings of a tanked water heater outperforms a tankless water heater by a factor of 5 or 10. And so nobody should ever have been encouraged to put in tankless water heaters. DOE did it, shame on them.
Great.
Now,
Another
let
couple
me explain what's hybrid about this water heater, why it's so efficient. Why is it 4 times as efficient as a standard water heater? And the reason why is because it has I'm gonna go to a video that I made. It has literally a, let's see if this is the right one. Yeah, this is the right one. So this is a presentation that I made for another purpose, but it's going to show, I'm going to go quickly to what a heat pump water heater looks like. And here it is right there. This is a heat pump water heater. This is almost identical to the same unit here. This is what this looks like on the inside. The top of this water heater is literally an air conditioner. Namely, it's cooling the air and drying the air to put heat in the water heater. So that means your water heater is not just a 4 times as efficient water heater than you have, but it's cooling and drying your home. So it's actually doing about a half a ton of cooling. Talked about before the sizing of the air conditioner. You can make a smaller you can have a smaller air conditioner because of this thing's actually cooling and drying your home. And it takes that air, that heat that it gets out of the air and puts it in your tank. And the energy it takes to do that is 1/4 it is than it would be if it didn't do it this way. And that's why it's called a hybrid, because it works either in air conditioning mode or with a heat coil. And I always set my units so it never runs with heat coil, but that's why it's called hybrid. That answer your question?
Yes.
I think so, yeah. We've got several more coming in for the chat and Q&A, so I'm trying to keep tabs on it, but we had a couple about windows, specifically vinyl windows, good or bad. And if you want to keep your old wood windows, how do you make them more insulated?
I actually had a window that I was going to open on that, and I decided to not use it in this talk because let me see if I can get to the closest thing about that. So this is the one that's closest to that. Okay, so this is the window right here that you're talking about, and it turns out these windows can be retrofit, and according to Susan, you guys are going to have a whole talk on it, and it's not that hard to do, but it's never going to be super energy efficient like a new window. However, that segues into my favorite joke on energy efficiency. So this guy got a phone call from the window salesman. And he said, "When are you going to pay me for the new windows you bought?" And he said, "Well, call me back in a month." And so he said, "Okay." So he called him back in a month, and he said, "When are you going to pay me for the new windows?" And the guy says, "Call me back in a month." So he kept doing that for a year. And finally, the guy says, "Well, when are you going to pay me for the window?" He says, "Well, you must think I'm really dumb. You told me these windows would pay for themselves in a year." Okay.
You should use that on any window salesman.
Every window salesman deserves the same grief. Windows do not pay for themselves in a year. In fact, most window retrofits like this can take 30 years to pay back. That's because the cracks around the windows are way smaller and the energy flows are way smaller. On the other hand, one of my favorite experts in around 1985 said that the average home in this country has a crack through the walls of a square yard. So you take all these holes, not just the windows, but this hole, this hole, this hole, and add them up. The average is here between the living space above and an attic. Add them all up, and it's a square yard of holes. And that's a tremendously expensive hole, as we talked about before. When you make this home, you go through all the steps, you save, $200 to $500 on your air conditioning and heating bill. That's an expensive thing. But one particular item is just not going to get paid back. This might cost $100 to $500 for that window, and it's not going to generate savings and pay for itself in a year, but maybe 20 years. Now, how to do that? Well, you're going to have a whole talk on this, and Susan, you can tell them when that's going to be. I don't know.
We are planning a whole bunch, like I mentioned in the beginning, of home maintenance programs, and definitely windows will be a part of it. When we get the schedule up, if you subscribe to our mailing list, which you can do at prcno.org, you'll get alerts. Also follow us on social media and in Preservation of Print.
I will point out that's the airtightness of the window, way, 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 way more than its R value. Windows have R values. You can have double pane windows and even argon put between the glass of the windows, and you can put radium barriers on the windows. All that's nice, but by far, the most important thing a window needs to do is stop the airflow, and that doesn't require new windows to do. It's not easier to do with old windows, but it can be done, and it's not super hard.
You and I, before this talk, had talked at length about weather stripping. You want to just touch on that and the importance of it?
Well, weather stripping is a big part of what this whole team would do at this particular website. And there's a lot of things you do. Sometimes you use caulk things, certain kinds of caulk. There's also some strips that you can buy. I might be able to pull it up quickly if I go to, say, the Home Depot website and bring up something. I'll go over here. And so let's see, V-Groove weather strip, and see if it comes up. And this is V-Groove weather strip. And you see how it's a V like this? This particular one isn't the one that's the V. This is the one that's the V right here. It's and this comes off in a piece of tape, and then it's 1 inch wide, and it's got sticky on one side. Here's the sticky side, and you fold it, into a V. See this shape? You fold it into a V. So just make sure you can see that. This is what you want to do. You literally put it on the door jamb, and then when the door closes, I don't know what this is. Okay. Anyway, so that's how it works. You can put it over here between the door and the say the hinge side, or you can put it jammed. And this is the best, the simplest way to do it. You can do this on windows and doors. You have to figure out where to put it. If you put it in the right place, it'll stay there a long time, and you'll still be able to use the solution. And I highly recommend it. I've been in this business for 30 years. It's by far the best solution, cheapest solution. It's amazing. People say, oh, how could the cheapest be the best? Well, sometimes it is. Okay. So did I answer your question?
I believe so. We've got a few more questions about spray foam. So just to reiterate, you were recommending against spray foam in crawl spaces, correct?
Yes, I might be able to pull up a picture from one of my clients' houses, but I don't want, if I browse to it, you'll see his name, and that would be unethical. But anyway,
that's okay. I don't want to ask you to repeat yourself. I just wanted to make sure that was clear.
Spray foam,
Kind of like
has
drinking
many,
from a
many
fire hose.
problems. I mentioned them. I do not recommend them. There are places for foam that's previously been set, like the foam boards I was showing on the sides of the crawl space solution, which over here, I believe it's this one. Okay. So this is a preset foam board that was put in a cast and set. It's literally styrofoam. One beautiful thing about styrofoam, when it gets hot, it doesn't burn, it melts. And so it's not a fire hazard. Some other foams I don't know about, but in any case, so foam, there's two kinds, roughly: open cell foam, closed cell foam. Open cell foam, when it gets wet, moisture flows right through it, like it throws through wood or cellulose or fiberglass. Closed cell foam, it's a water barrier. Both of them are air barriers. Both of them have problems. The problem with closed cell foam is when you have a leak, not if you have a leak, there will always be a leak. There'll always be a roof leak. There'll always be a leak on a floor. There will be a leak, and you won't know where the leak is, and the wood near it is going to rot before you find out about the leak. Okay. Open cell foam has almost the opposite problem. When it gets wet, it transmits the moisture everywhere. So if you have a leak over open cell foam, you'll see the leak, you'll see the drip, but you may not see the drip anywhere near where it happened on the top. So it's actually in the way of good building maintenance. And as I said, it's often put places where some other insulation would work better. And so I just don't think there's any place for foam in a home, except for, like I'm saying, in this crawl space solution, where it's not really in the home, it's on the side of the home.
Yeah, and is there a specific type of the foam board that you would recommend?
Well, it turns out right behind these weather boards, I use polyisocyanurate foam, which has an R7 per inch. Styrofoam has probably around R3 an inch, which is more than twice as high an R value. And so where the thickness matters, like I'm going to put it behind these weather boards, and I don't want the weather board to stick out past the side of this veneer, so I need a high R value. But over here, I want something cheap because I don't care how thick this board has to be to get the R value I want. So where you need high R value per inch, I would spend extra money for the polyisocyanurate. Where you don't, I'll use the styrofoam. But but again, you have to be very careful where you use it because you do not want to create a moisture problem.
And for someone who wasn't going to use this strategy of trying to sort of mostly air seal under the crawl space, what about bat insulation under a crawl space or under floorboards? That was a question.
It's a very interesting question. I actually had to deal with it for this particular home. I had a choice. I could put the bat insulation between the joists, or I could put the foam along the walls. Turns out the difference in cost is like 3 to 1. This is way cheaper. the labor alone is way, way cheaper. Materials are about the same or half the price. No, actually, the total amount of money I spent on the materials here is under $200, and I would have probably spent $800 on fiberglass bats. Then there's a big problem. Do you put the bats with the paper side down or the paper side up? And I can tell you, if you ask 100 building scientists, half of them will give you the opposite answer. But I decided I wasn't going to ask any of them. I spoke to a guy who owns a flooring company, and he tells me absolutely for sure, put the paper side up so it's touching the wood, which is counterintuitive because that means if cellulose, that's a fiberglass bat's not an airtight cavity. And he doesn't really care if the insulation works. All he cares about is the floor doesn't get ruined because his floor is what he recommends. So he doesn't really care if the R value of insulation works at all. All he cares about is that there's a moisture barrier underneath the floor that doesn't cause the floor to warp. However, people who don't care about that because you're not in the flooring business would say, okay, why don't I put the fiberglass, the foam side, the paper side down? Well, the trouble is, what you did isn't airtight. So the moisture is going to get into that fiberglass, and the fiberglass will literally get so wet that it'll fall through the paper backing, and you'll find it on the ground in a couple of years, which means you accomplish nothing. And before it fell down, you drastically endangered the joists and the floor.
Plus, you can get critters, right? You can get squirrels and rats and things living.
All kinds of things. It's just a really bad idea. Insulating between joists is extremely problematic in our climate. This is by far the best solution for many, many reasons, and it avoids those problems. Okay, another problem with crawling into crawl space is how do you avoid getting electrocuted? Okay, because all those wires are there. And I don't want to take a chance of somebody getting electrocuted. I don't care how much money I'm saving. This way, I don't have to worry about it.
Wow.
Another thing, I can inspect it. I know what's going to happen. When I call a plumber or an electrician to work in this crawl space, I know the foam board is like he found it because he knows I can see what he did. But if he goes and upsets some insulation in the crawl space, whether it's fiberglass or cellulose or foam, he knows I'm not going to see what he did, and it won't be there.
So sort of a related question, but flipping from the crawl space to the attic space, could you go over in a scenario where someone is doing insulation in the attic and then doing a barrier, what side of the insulation should the barrier be on? The conditioned side or the unconditioned side? Okay,
so are you talking about a say a fiberglass on the floor of the attic, say right here in the picture, and you want to know which way should it face, okay? And the answer is it's irrelevant, because the right answer is this. You need to cover you need to cover the space with plastic, okay?
And did you put the plastic down before you put the insulation or after? I think maybe that's what the question is.
It turns out the answer is yes. Namely, you should put it before, during, and after. But if you only put it over, it works really well. This is so if you just put it, what actually happened is this guy was a high school student when he did it. And we actually measured it. I know it doesn't look good when you highlight, so I get rid of it. We actually did it, put a box with foam and insulation in it. And the R value they actually measured using the test this high school teacher told me to use, he measured an R value of 1/30th of the rating of the insulation because it wasn't an airtight barrier. So then he decided this was this box test, and he measured all these temperature measurements, you do calculations, you find extremely low R value. And then he said, well, let's put some plastic over it. So he used insulation, and then we just try to put some polyethylene over it, and he got a much higher R value, okay? And then he said, well, this is higher R values. And then he said, well, maybe we'll use 2 sheets of plastic. Maybe we'll put sheets of plastic in between. It turns out the more plastic you put in, the higher the R value got. In fact, he got R values up to the rating. So let's talk about an R value of 30 of this fiberglass insulation. No plastic, he gets an R value of 1. Plastic over the top, he gets an R value of 10. Plastic between, namely 2 layers, he gets an R value of 30. Namely, he doesn't get to 30 unless he does all this plastic. You say, well, how can it be that fiberglass insulation performs so much more poorly than it's rated. And that's because insulation is always rated in an airtight container, but never installed in an airtight container.
Interesting. So even if someone had already had their attic had blown in insulation in it, they could still benefit by putting a layer of plastic on top of what they have. And
you know, it increased the R value by a factor of 10. He thinks he has an R value of 30 because he has, say, 6 inches of cellulose, but he actually only has an R value of about 2 because there's an airflow in it. You put the plastic over it, and the R value goes up to 10, which is still 1/3 hoped for, but it's 10 times better than we got before I put the plastic up. And the thing about it is, when you put plastic over it, someone's going to say it's going to fill up with moisture. But this test, and it depends upon the plastic. The plastic has to be no more than 2 mils. So anybody doing this without reading this report was likely to do it wrong, because if you put 6 mil plastic up there, you will cause a moisture problem. But if you put 1 mil, the heat of the attic will actually dry the insulation, improve the R value. That's all explained in this report.
And that's on your
That's
website?
great.
That's on my webpage. I'll show you. I'll go backwards in my webpage. If I go backwards in my webpage here, I'll show you where it is. See?
Also, this Word document with all these links is on your website?
Yes, I'm going to show you where it is on my website. So it's over. Let's see. Let's see, where is it? I forgot where I put it. Wait a minute. Maybe put it over here. No, I think I put it over here. Let's see. I can't remember where I put it. Let's see. Nope, it's not here. Let's try here.
We can email it to everyone.
Alright.
We have everyone's contact information that signed up for the program, and we'll email it to them.
I sent you a link.
Yeah, I
with
think you did.
information. And it's on the website somewhere. I forgot where it is. Well, maybe it's under publications. Let's see. And enter presentations. That's where it probably is. And nope, not there. Oh, well, it's somewhere.
We'll get it to people. We'll get it to people.
And it's an exact copy of this Word document. And to show people one of these things, this is a link. And you can see it's the links popping up on the screen when I go over it. But because this is not a PDF file, this is a Word file, you need to right click on it, and then you can make the choice. So if you right click on it, you could say open hyperlink, and then it pops up on the screen as an open hyperlink right there. See?
Great.
Okay.
that's great. And so the short answer there was not too thick plastic, something like a 1 mil.
1 or 2 mil plastic belongs there. And people don't know how thick plastic is. It's easy. You already know. If you use a sandwich bag and you put a sandwich in the freezer, it comes out all dried out. But if you use a freezer bag, it will stay moist. The difference in thickness is what we're talking about. The sandwich bag is 1 mil thick and the freezer bag is 6 mil thick. So you already know what I'm talking about. Okay.
Nathan, I think we're going to probably need to wrap up at 7:30. I know we have so many more questions.
Well, I got a couple of early questions that, yeah, I don't think we can get to everyone, and I'm sure I haven't caught them all and trying to stay on top of the chat. But while we're still in the attic space, someone did ask about the value of a radiant barrier in the ceiling joists if they have a metal roof. Is there any differentiation there?
Yes. Turns out metal roofs are way better at keeping heat out. The best roof you can put on for energy flows is the white metal roof. It works so well that there's no point in putting the radiant barrier up. However, you know, I'm anal, I'll do that anyway. But it turns out a white roof is about the best radiant barrier you can get. And without anybody's roof, you can put a radiant barrier underneath. And one of the interesting things about radiant barriers are they shorten the life of the roof. And you'd say, well, is that a deal? And the answer is no. We're talking about a 1 to 2% shortening the life of the roof. And when the radiant barriers first became popular in Florida, there were roofing manufacturers who were suing the people who were promoting this and saying, if you do this, you're going to lose your warranty on your roof, which is like a 30-year roof. Most people never experience 30-year roofs. They fall apart for different reasons, like a hurricane. So it doesn't really matter. But the fact is you get about a 1 or 2% loss in life of the roof because of the radiant barrier, because the heat doesn't get to cool toward the bottom and only can cool toward the top. It's true, but it's almost irrelevant. And that's because Roofs come in various colors. A white roof won't heat up as much as a black roof. And the difference in color of the roof is more important than whether there's a radiant barrier underneath, but the manufacturers of the roofing top shingles don't say, oh, the white roof has a 35-year warranty, and the black roof only has a 25-year warranty, even though if they were honest, they should say that.
Fascinating. Well, so we're hitting at 7:30. I want to be respectful of everyone's time, but we'll have one last question for you that was asked early on that I don't want to brush off. And that was from someone who has pocket doors in their old home. And they're wondering about leaks through that pocket door cavity that they're losing, as I read it, losing conditioned air into their wall cavities because of the pocket doors. Is that something to be concerned about? And is there a fix?
The answer is definitely something to be concerned about. The problem with that, actually, the historic home that I'm working on, 140-year one that you mentioned, introduced me, has these big pocket doors. They're beautiful pocket doors, but they're a nightmare to seal and insulate. You need to seal them on the top, and like this is, think of this as the pocket door. Well, in the actual, my home that I'm fixing, there's a hole in the floor where the pocket door goes. It's all the way up. So you need to cover that hole and then put your insulation on top. But that's not the whole problem. In this case, it's luckily, we're looking at a pocket door like space toward the outside. And you also need to seal the outside. And if you have regular weatherboards up there that were put up 100-something years ago, like mine, and you just fill this cavity, it's just going to go right in and fill the cavity with the pocket door. And you do not want your cellulose, your fiberglass going into the area with the pocket doors, which means you need to put a barrier. You need to take off the weatherboards, at least half of them, so enough so you can slide a foam board right in here. This is an excellent place for a foam board. So you slide a foam board here, right in there, and then you can seal this cavity, and then you can insulate outside from there. And you have to seal at the top, and you need to seal at the bottom and the sides. And the bottom is already sealed, namely it's a continuous floor under it, but you might find one that doesn't have that. You need to seal it on the bottom. You got to seal all the way around it. It's a pain in the butt, but it's got to be done if you want to have a home that's sealed.
That's great. That's a good answer. And I am reminded of a piece of advice I was given by a friend long ago who works in the building sector and with a focus on thermal comfort and energy efficiency. And his words were, air is very, very small. And that was his guidance, that how you would create a more comfortable and efficient space, was to bear that in mind. Air is very, very small. And so any little crack, it will find its way through eventually.
Now, another assertion, which is similar, but I can't remember the exact quote, but a hole in the wall the size of your finger could actually be equivalent to the heat loss of maybe 10 square feet of wall. So a well-insulated wall will send out heat flows, but a hole in the wall the size of your finger can let air in and heat in faster than 10 feet of square feet of wall. Wow. So the holes are way, way more important. You need to do that. And that's the reason why one of the questions on the list, which was I didn't get to, but I'll show it to you. The last question on the list was, here, I have high energy bills. I could run my HVAC for 24 hours and still not heat up my home above 61 degrees. That's obviously a leaky house. And I don't care if your house is leaky, it doesn't matter how good your heating system is, you're not going to catch up. And that's what we have, leaky houses. Okay.
So the moral of this whole story is seal up your house.
Well, I mean, I think this is the solution right here. I'm just going to highlight it. It's by far the most cost-effective thing to do in all homes is right here. Make your home tighter than 1/3 natural air changes per hour, very well insulated, and then make your home effectively built on a slab. You do those two things and you cut your energy bill in half. You'll be able to put in air conditioners that are half as big, and your energy bill, this is the key to it. And this entire retrofit, my guess is probably under $2,000, maybe $3,000, the most challenged home. It's just very, very easy to do. It's not, it's counterintuitive, way cheaper than insulating some other way. But of course, they're going to have the pocket door problem, which is going to make that home easy. I mean, hard. They're going to be the unusual cases, but you got to do it.
All right. Well, thank you so much, Dr. Katz. There's some folks expressing their gratitude in the chat as well, saying this has been excellent, but overwhelming. And I think that's probably a good summary. It's a lot of content. And so we'll be happy to have you back for some additional programs and to incorporate some of this into our other programs through our forthcoming maintenance course and other special events.
It's my pleasure, and I feel very, very complimented to be asked. And if I could put a shameless plug, and it's not really shameless because I don't make any money on it anyway, is I'm promoting electricity rate design that is time dependent, which would allow you to buy electricity when it's cheaper, like the windmills in Iowa, and get the advantage of that. And it's very, very good for the environment that we buy electricity when it's cheaper, because we buy it when it's cleaner. And if we have the economic incentive to do it, we can make money. And even a simple electric water heater, which is this slideshow I was talking about over here, I think, where if we choose a regular electric water heater with a retrofit we're talking about, just regular electric water heater will generate $185 a year income just by changing when you charge it. From charging at any time to charging it in the middle of the night, you can get this much income. And that's only available with this time of use rate, which is called CLEP, that I'm trying to propose. And if people get excited about my deep understanding of building science, maybe that'll segue into respect for my ideas and generate a groundswell toward a solution that can help save your money, save the environment. Maybe New Orleans would be a place you can walk in 50 years instead of swim.
Let's hope. The comment that this was fascinating, but also overwhelming really just underscores how much of a topic this is that people care about and really want to know more. And we'll try to take deep dives on specific elements of this. This was, incredible, Dr. Katz, that you could give us this big overview. Maybe we could come back and do segments that are more specific to different topics that are on this.
Thank you very much. I'm very, very complimented. One more comment is I'm applying to DOE for opportunity to spend $7 million in New Orleans and to bring this kind of technology to over 100 homes and change some of the homes to be, 5 times as energy efficient as they are. And there's a particular kind of home which is common in New Orleans called a lipstick on a pig home. And it's worth talking about. Turns out that term was invented in New York to handle the used car salesmen who polished the cars so they could sell them, even though they never fixed the engines. So they call lipstick on a pig homes. And then we think we have maybe 25 megawatts of lipstick on a pig homes. Namely, there's 45 megawatts of rooftop solar in New Orleans. And probably a third or half of them don't have any energy efficiency on them. They just have the screens. So if we were to improve their energy efficiency, we would free up half the solar panels to be useless at that home. Well, this rate design allows someone else to rent those solar panels. So we get 100 kilowatts of distributed community solar, and anyone in the city can rent part of it. And it's a win-win-win-win. Poor people get cheap solar, and the home owner that is living on a pig gets a energy use, and they make money renting the solar panels to someone else. And we create an industry where we never had one before, and we solve climate change all at the same time.
Well, if you get that from the Department of Energy, you definitely let us know, and we will come back and do another program on it.
I will. Thank you so much for having me. And as you can see, I'm really deep into this. It's my pleasure.
Well, we really appreciate it.
Okay. Thank you. I hope I met your expectations.
Oh my goodness, in spades. And I would love to just tell everybody that stay tuned to our social media, stay tuned to Preservation and Print, because we will bring Dr. Katz back if he will come and deep dive on a couple more of these topics soon. And please become a member, prcno.org.
Okay, thank you.
Good night, everybody.
Good night.
Good night, everybody. Thanks, Nathan and Daniil.